Question 4c asks, using a rapid equilibrium approximation, derive the rate expression for the overall reaction. So whenever we're looking for a rapid equilibrium approximation, we first want to know what our rate determining step is, or the rate law for the rate determining step. So as we solved in 4b, we know that the rate determining step is equal to K2 multiplied by CLO squared. At this point, it's simply a matter of trying to isolate CLO from our overall elementary reactions to get a rate law that does not include the species CLO. So one thing we can do is, looking at our first reaction, CLO NO goes to NO plus ClO, and this is K1, and our reverse reaction is simply the reverse of this reaction. So at this point we can isolate our ClO by dividing the left side by NO. So we can do the concentration of ClO is equal to K1, because remember we're going forward first prior to doing the isolation of ClO. So it's equal to K1 multiplied by the concentration of ClO NO divided by the inverse of K1, so the reverse reaction, divided by the concentration of NO. So plugging this equation into our overall rate expression, we get that our rate is equal to K2 multiplied by, well, we know that ClO is equal to this large expression here. So actually take away these brackets. So it's equal to K2 multiplied by K1 times the concentration of ClO and O divided by the inverse reaction multiplied by NO, and that's all to the power of 2. Now, depending on the professor that you have, this form of the equation might be fine. However, some professors might want you to simplify this. So by simplifying it, you're simply giving an overall K value, which is equal to, you can call it large K, which is equal to K2 multiplied by K1 divided by K negative 1. And then putting this in simplified form, which equals ClO NO squared multiplied by NO to the negative 2.